Hi everybody. This is Activity 5, Isotopes and Average Atomic Mass Class Debrief. Remember, anything written in red should be recorded in your lab notebook. So if you don't have that, please go get it at this time, pause the video, and then restart when you're ready. Okay, let's start with a recap and a review. What are the three subatomic particles? Very good. Protons, neutrons, and electrons. What subatomic particles determine the atom's identity? Protons. Protons are the only one that determine an atom's identity. It is the atomic number which is specific to each element. It is what is unique. How is the atomic mass of an element determined? The atomic mass is determined by taking the sum of the protons and neutrons in the nucleus of the atom. That means add them up. Add the protons and neutrons together, and that gives you the atomic mass of the atom. Why is the mass of the electron not used determining atomic mass? The mass of the electron is so small that it's not significant in the overall mass of the atom. It's just too tiny. All right, so let's move on to isotopes. So what is an isotope? Isotopes are atoms of the same element with different numbers of neutrons. So what that means is two or more atoms would have the same number of protons or atomic number, but different numbers of neutrons. Remember, it's the protons that make an atom who it is. Let's look at an example. So here's an example of carbon. Carbon has three different isotopes. Those isotopes are called carbon-12, carbon-13, and carbon-14. Take a look at the number of protons in each of these carbon atoms. You'll notice that each of these carbon atoms has 6 protons because it's the 6 protons that makes carbon carbon. What's different is that each carbon has a different number of neutrons, and therefore they each have a unique mass number. We identify isotopes of atoms by their mass number. So let's look closer at carbon-12. Carbon-12 has 6 protons and 6 neutrons. We add those together, we get its mass number, which is 12. And we call this isotope of carbon, carbon-12. Carbon-13 has 6 protons and 7 neutrons. Added together, that gives us a mass number of 13. So this isotope is called carbon-13. Carbon-14 also has 6 protons, but this one has 8 neutrons, which gives it a mass of 14. 6 plus 8 is 14. And we call this carbon-14. Isotope notation. Isotope notation identifies the mass number or the total number of protons and neutrons in a particular atom. It will be different for isotopes of the same element. Atomic numbers also located on our isotope notation. Remember, the atomic number tells us the number of protons in an atom. And this will be the same for each of the isotopes. If we take a look at the isotope notation at the top, you can see that the A is the location of the mass number. This number is going to represent both the protons and the neutrons, so it will be the bigger number. Z in the bottom left-hand corner is the atomic number and represents the number of protons only. Underneath is an example of the isotope notation for lithium. Lithium has 3 different isotopes. Lithium 6, lithium 7, and lithium 8. Notice that they all have the same number of protons, 3, and that 3 is written in the bottom left-hand corner. In the top left-hand corner is the mass number for each of them. They all have the same number of protons, but they have different mass numbers because they have different numbers of neutrons. How do we determine average atomic mass? Average atomic mass is determined using each isotope's mass number and its abundance in nature. Abundance in nature means how common or often it's found. The average atomic mass will always be closest to the mass of the isotope that has the highest abundance. So the one that is most abundant in nature is the one that will be closest to the average atomic mass. So let's take a look at our example of silicon. Silicon has 3 isotopes, silicon 28, silicon 29, and silicon 30. If you look at their percent abundance, silicon 28 is the most abundant. It has a percent abundance of 92%. That means if I were to have 100 silicon atoms, about 92 of them would probably be silicon 28, about 4 or 5 of them might be silicon 29, and about 3 of them would be silicon 30. So you can see silicon 30 is the least abundant of the atoms. Let's stay on this screen for a second. If you look at your periodic table for silicon, you'll see that its average atomic mass is 28.0855. So if I round that to a whole number, that rounds to 28, the same as the isotope that is most abundant. Practice. Who would this be? Given this information, which one of these atoms could this be? Carbon 14. Carbon has 6 protons. I know that because I can look on the periodic table and see that its atomic number is 6. And in this picture, there are 6 protons. I can also see that it has a mass of 14. So 14 minus 6 equals 8. And those 8 would be the neutrons that are also in the atom of carbon. Practice. Which of these pair of atoms are isotopes? All right, the answer is pair C. The reason these are isotopes is this is the only pair that have the same number of protons. They each have 12, but different numbers of neutrons. So therefore, pair C could represent a pair of could represent a pair of atoms that are isotopes. In nature, chlorine has the following composition. This picture might look familiar from the PhET simulation. We can see in the picture that chlorine 35 has a percent abundance of about 75.76%. That's represented by the purple part of the circle. Chlorine 37 has a percent abundance of 24.24%. That's represented by the green portion of the circle. Considering this, the average atomic mass of a natural sample of chlorine is very good. It's got to be between 35 and 36. So if I take a look at this, chlorine 35 is the most abundant. That means that the average atomic mass is going to be closer to chlorine 35 than it is to chlorine 37. Neon has 3 naturally occurring isotopes: neon 20, neon 21, and neon 22. Which isotope has the highest natural abundance? Take a look at the periodic table square for neon that's provided for you in the top right-hand corner. Very good. The answer should be neon 20. If we take a look at neon's average atomic mass, it's 20.18. If I round that to the nearest whole number, that's 20. That helps me to decide which one of neon's isotopes is most common. Its most common isotope would be neon 20. Magnesium also has 3 naturally occurring isotopes: magnesium 24, magnesium 25, and magnesium 26. In a sample with an average atomic mass of 24.98 AMU, which isotope is the most abundant? Very good. How I know this is I take a look at its average atomic mass, which is 24.98 AMU, and I round it to the nearest whole number, which is 25, and that identifies for me the most common isotope of magnesium, magnesium 25. All right, that's the end of our notes. At this time, you should finish up your Activity 5 packet. Make sure you've checked your work and you've turned that into the sub, and then move on to completing the Activity 5 concept check on Schoology.